In this section, we're going to talk about quadratics. Now, quadratics allow us to graph parabolas on a coordinate plane, and they're always going to be represented by having some number times x squared plus some number times x plus some constant number. Now, if any of these are missing, for example, if my 6 is gone, that will just be represented by 0. But each number that's next to x squared will be considered my a value. The number next to x will be my b value. And the number that's by itself will be my c. Now, it can be in any order. It doesn't necessarily have to be a, b, and c. It could be mixed up. This could say 6 plus x squared plus 5x. And still my a value would be in front of x squared, my b value in front of 5x, and my c value at the end. Okay, the different types, different things that we're going to figure out about these parabolas from this quadratic are listed here. From this equation alone, I can figure out whether or not the parabola will be going up or down. I can find its axis of symmetry. I can find its vertex, whether that vertex is a minimum or maximum, the y-intercept, the domain and range, and the zeros or the roots of this function. So the first thing I'm going to do is talk about how we can figure out whether it's up or down. Now, we know that our parabola is either going to be facing up or down, and by that I mean if it's facing up, it's opening up. There's going to be a minimum point for the vertex, and these values will continue on forever and ever. If it's facing down, it's opening up down, where I will have a maximum value, but it will go towards negative infinity in terms of the y's. And we'll talk about more about that when we talk about domain and range. Now, what's going to tell us whether the parabola will be facing up or down is my a value. If my a value is positive, that means it's going to be facing up. If my a value is negative, that means it's going to be facing down. And again, it does not matter whether or not that x squared is here in the equation or at the very, very end. It doesn't matter. Okay, the a value will be the number next to x squared. Here that value is 1, so I know that my parabola here will be facing up. The second part is finding the axis of symmetry. The axis of symmetry is where your parabola will be divided in half. Okay, this here is the parabola for x squared plus 5x plus 6. So my axis of symmetry is the vertical line in which it will divide this parabola vertically, okay, into two separate equal halves. Now, that value is going to be the x value of my vertex. And there's a formula that goes to finding that. That formula is negative b over 2a. And again, my b and my a coming from my original function. So what I need to do is plug in the 5 for b and the 1 for a. And I get negative 5 over 2 times 1. So 5 divided by 2, or half of 5, is 2.5. And I'm going to be multiplying it by this negative after I go ahead and find that quotient there of 5 divided by 2. So this will end up being a negative 2.5. So that is my axis of symmetry. That is my x value on my vertex here that will divide straight through this parabola. Now, this also helps me figure out my vertex, because this answer of negative 2.5 becomes the x value of my vertex. So I know that my vertex is a coordinate of x comma y, and right now I already know my x value, which is 2.5. The way that I find my y value is by taking this x value and plugging it in to this function. Negative 2.5 squared plus 5 times negative 2.5 plus 6. So if you do negative 2.5 squared, you'll get a positive 6.25. 5 times negative 2.5 would give me a negative 12.5. And then at the end I would have plus 6. So if I do 6.25 minus 12.5 plus 6 in my calculator, I end up with a negative 0.25. And what this ends up being is the y value of my vertex. So this ends up being negative 0.25. Now, a problem that people sometimes have, especially when you become dependent upon a calculator, if you say negative 2.5 squared in your calculator, it'll come up as a negative 6.25. Because the way that the calculator does it is it squares the number first and then multiplies it by the negative. But we know that any number, whether it is positive or negative, when squared, becomes a positive. So that's why it should be a positive 6.25. Alright, so now I have my vertex at negative 2.5 and negative 0.25. Part D asks me to find my minimum or my maximum. Well, since my A value is positive and it's pointing up, that means that I will have a minimum value. So that vertex represents the very minimum point, the lowest point of that parabola. So I know I'm going to have a minimum, and that minimum will be at that vertex of negative 2.5 and negative 0.25. Part E asks me to do my y-intercept. The y-intercept is equal to the c value in your function. So if I go up here, my c value is 6, so I know my y-intercept will be at 0, 6. Remember, your y-intercept is not 6. That is where it's crossing the y-axis, but a y-intercept is a place on the y-axis that has an x value and a y value, so it would be 0, 6. The domain for any of these functions is going to be all real numbers. And that's going to be represented by this symbol. It's like an R with two backs. The reason it's going to be all real numbers is if you look at these two illustrations, these parabolas will continue on forever and ever and ever, and my x value will continue to become more negative and more negative as it goes left, and then more positive as it goes right. And there's no way to calculate its endpoint. So all real numbers will be that domain. My range is different. Within my range, if I have a minimum value, my range will go from that the y point of my minimum value, so here negative 0.25, and it will go all the way to infinity. Now, if I would have had a maximum value, that means I would have a top point. And it would go from negative infinity to whatever the y value in my vertex would be. But if you use a negative infinity, it always goes first in your range. Okay, if you do a positive infinity, it would always go second, and then the number will be placed, your y value would be placed either first or last, depending on whether you have a minimum or a maximum. The very last concept is finding the roots. Okay, the roots of the quadratic is based on you factoring out this x squared plus 5x plus 6. We learned about factoring, and the way that you factor this quadratic is by finding two numbers that multiply to make 6 or add together to make 5. Now, sometimes you have an issue because the two numbers that you multiply to make 6 and add together to make 5 are decimals. If that's the case, then you need to use the quadratic formula, the x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, but here I'm in the clear because I know that 3 times 2 not only multiplies together to make 6, but also adds together to make 5. Now both of these separate polynomials here will come together and say x plus 3, and I will set that equal to 0. Then I will have x plus 2, and I will set that equal to 0. When I solve for x, the two values that I find will be where my parabola is crossing my x-axis. Those are my roots, also known as my zeros. So what I want you to do now are numbers 2 and 3. Here are the two different functions. And I want you to go through and solve for 2 and 3, the same thing, A through G. And you need to do both of them in order to receive credit for this set of notes.